Hello everybody. So in the last class we spoke about who are the fathers of a data warehouse and what is the concept of a data warehouse. Okay. So today let's learn about what is OLTP database. We already covered in the demo part. At the same time we also learn what is OLAP database. Okay, fine. So now let's try to see the differences between these two, OLTP and OLAP. So now the first step is let's have the first point like OLTP. Let's try to abbreviate this. So what it is nothing but it's online transaction processing database. Similarly, here we can write like it's online analytical processing database. So here in OLTP database we will be having all the current data or we'll be having the transactions which are processed online. So that is the reason being I could say that this OLTP contains it contains current data always, whereas in your OLAP, so what is OLAP? So OLAP is it is useful for us to do some kind of analysis part. So in order, as I said earlier, your upper level people and your middle level people, or I could say that higher hierarchy people need your historical data, so that based upon that they try to do some kind of analysis and finally they take the decision on the business so that they can improve the business. Okay, so finally I could say that in my OLAP I'll be having my historical data. So next, what kind of data we have here, or who has access on our OLTP database? So if you remember earlier, I spoke OLTP database will be having access to low level people, or I can say low hierarchy. At the same time, OLAP has access for high hierarchy persons your CEO, vice presidents, director, all these people comes under high hierarchy. Okay. Now, so in general, when you try to do some kind of transactions, so how do you write the transaction? Is it a detailed format, or do you it's like an overview? No, right? Generally we go with the detailed format. So I could say that in OLTP database we'll be having the data detailed data. But how could my data in OLAP database is? So in my OLAP database, so we know that OLTP database is nothing but it's a source to my OLAP. So the data can be taken into my OLAP as it is, or I could make it as a summarized data. For example, just in case I have very much detailed data in my OLTP database, but the client said that my database is very small, and at the same time I do not have the requirement where I could store all my transactions done by each customer. That means I don't want to store each and every transaction done by the customer. So what do you want? Or else I have such a requirement I just need to store what is the last transaction done and what is the end amount I have on my bank account. So the day one in the morning, suppose I have $1,000. At the end of my day, how many dollars you have in your account? Is it still 1,000, or is it updated to some $2,000? So what is the end amount at the end of the day? What is the amount do I have in my balance? So it's like a closing balance for the particular day. So I just want to know only the particular last amount of the particular day. So I don't want to know each and every transaction done by the customer. In that scenario, I could say that we'll be having summarized data, or the same scenario, the client may also ask that, okay, I need each and every transaction done by the customer because I have my record in such a manner. So I don't want to have summarized data only. I want to also have my detailed data as well. So for that reason being, you may also have your detailed data. So it's purely based upon your requirement how your clients require, you may either store summarized data or you may have your detailed data. Okay. So here one more thing, like when you have a detailed data, then you can drill up or drill down, right? Suppose I have day-to-day transactions in my database. Suppose I want to know what is sum of sum of amount I have at the end of my day. That means suppose like I have all my transactions. I have $1,000 at the starting of the day. Later on, I deposit $200, and later on I withdraw $150, and later on I withdraw some other $50, and later again I deposit $200. So this is nothing but each and every detailed transaction I'll be having in my OLT database. So if you want to get the whole as a sum on a particular day, yes, I can go with all my plus and minus, all my deposits and withdrawal, summing up all the things. Yes, I can go with my summarized data over here. That means I can drill up. And as well as I can drill down. That means I can even go more deeper as per my requirement. Similar case, but in this scenario, if you have summarized data, you cannot drill down. Because overall you are having the last closing balance. So suppose you think that at the end of the day you had only like the last one, that is your $2,000 finally. Suppose you want to know what are the different transactions done, then you can't drill up because you have only one amount and you do not know what are the different transactions done in between, and finally you got this particular $2,000, right? So we cannot drill down to detailed data. Similarly, if you have your detailed data, yes, I can drill down the things. Okay, so it's based upon your data you stored. Based upon that, you can drill down or drill up the things. Next. So how the data will be in this particular scenario? So the data will be keep on changing in my OLTP database. Suppose like I just ordered one product from so and so website, and later on for the same product I can cancel immediately. So the data will not be same. The data will keep on changing. So on the same data, it will be getting updated saying that this particular order has been cancelled. At the same time, I can order again on the same thing. The data will be updated saying that there is a second order again came up for the same product. So the data keep on changing in your OLTP database. For that reason being, I can say that the data is volatile in nature, whereas in your OLAP we should not make any changes to the data. So even though there's a changes of data, all the changes should be inserted into my OLAP. For suppose on the day one I just ordered one product, and later on I cancelled it, as we had in your OLTP database. So in your OLTP database, the data has been updated on the same row, but in here that's not the case. So what is the product you ordered, that particular row will be available in your OLAP database. And similarly, if you try to cancel the product, then yes, cancel the order, then yes, even that particular record also will be available in my OLAP database. Okay, so I could say that in OLAP database the data will not change. So data is non-volatile in nature, and we know that this is one of the point said by our father, right? So these are the important differences between your OLTP database and your OLAP database. So overall I could say that OLTP database is a database where it contains your current data or live data, where it has been accessible by a lower hierarchy, as I said earlier. At the same time, we are the persons who are trying to do the transaction. So it will be contain your detailed data, and based upon this data we can either drill up or drill down as per our requirement. and at the same time the data keep on changing in my OLTP database. Whereas in OLAP database, it's like we do not do any kind of online transaction inside that, but we will be having the static data over there, where this data is useful for your analysis purpose. That is the reason being we have the word like analytical processing database. So since you do your analysis over here, that is the reason being it's called as your OLAP. And as we said earlier, this contains your historical data, and this data has been accessed by your higher hierarchy people. And you, as per your client requirement, you may either have your summarized data or detailed data. So if you have a summarized data, we cannot drill down even more, because you have only the last account. Suppose I'm talking about the account balance, you will be having the only last balance amount value, but since you do not know how you got this value, you may have multiple deposits, you may have multiple withdrawals, but finally you had the last amount at the end of the day. So you are trying to store only the last value. For that reason being, you cannot drill even down to know what are different transactions are done to get this particular value. So you cannot drill down if you have a summarized data, and you can again drill down if we have your detailed data. So I can write like, we can drill down when it is detailed data. And finally I could say that data is non-volatile in nature. That means the data in my OLAP never changes. Once inserted, that's it. It should be there only. So even though you have your, because this is like OLAP contains the total historical data. So if you keep on updating on the same record, then your historical data is gone, right? So the whole, if you want to maintain your historical data, then yes, you should maintain the data in static manner. So data is once inserted, I should not change. Okay, that's what is the difference between your OLAP and OLTP databases. So the other main point in here is like, it contains, OLTP database contains your master data and transactional data, whereas OLAP contains dimension table and fact table. So we try to understood what are all these things here, right? We try to understand. So we understood all those things. Now let's try to understand what is this last seventh point. What is master data and what is transactional data, or what is dimension table and what is fact table. So let's try to see if the first one, what is your master data. So master data is nothing but it is the data where it has been created once and changes very occasionally. Okay, so what it is the data which is created once and changed very rare cases. I could say very rare cases. So let's go with the example, like we can have an example like opening of bank account. So when you try to open a bank account, or when you try to register yourself in any website, what are different things they ask. So you should provide the different things like your first name, your middle name, your last name, or like your SSN number. I don't suppose your permanent address, your temporary address, and your email ID, your phone number. So these are the different things generally you provide at the time of you taking your bank account, right? So in this scenario, so these particular details are been taken only once when you trying to open a bank account. So they will not be asking every time again and again, right? So that is the reason being this such kind of data is called as your master data. And if you see now, the first name, this one never changes, right? Similarly, middle name never changes, last name never changes, permanent address never changes, temporary address may change, right? This may change, and email ID also may change, have a chance of changing. Phone number, this also may change. So these changes will not occur in regular intervals of time. So temporary address, you may change your address once or twice in a year, right? Or maybe 3 years once, something like that. Email ID, this may also never changes, but nowadays a lot of things are happening around. So cyber crimes have been going on. So your email ID may be hacked or something happens like that. Then you need to change your email ID, or you want to stop that email ID. You want to create a new email ID. So this change also never happens in regular time. Similarly, your phone number, this may also never happens in regular intervals of time. So this is nothing but this is kind of records which you try to create for the first time, and changes in very rare cases. Such kind of data is called as your master data. And you know, all these things are nothing but can happen only in your OLTP data, because while you're trying to register yourself or when trying to open your bank account, right? All these things are nothing but you're trying to add a new customer. New customer or new things should come from your source system itself. For that reason being, you can find this particular master data in your OLTP database only. Now, next. Now, you know that we have the data over here, and to store the data in our OLAP or any kind of database, we should have a table, right? If you do not have a table, how could I store my data? So in order to store such kind of master data, and the table which stores such kind of master data is called as your dimension table. So the table which stores your master data is called as your dimension table. So what is the master data? Master data is nothing but it is a data which is created once and changed very occasionally, and such kind of data resides in your dimension table. So I could say that this is my employee dimension. Similarly, I could also have something like, I could also have the same thing with my employee, or I could have with the customer dimension. So this can be either customer dimension or employee dimension. For both the cases, you can have the same structure of tables. Similarly, I could go with something else like product name, product color, product size, product price. So all these things, suppose you have a new product launched, and this is the product name, you gave that color, you have color size, you have, and product size. So do you think that this details of this particular product will change every time? No, right? So once a particular product has been created, the name will never changes, correct? So this will never changes over here. And product color may change, but in very rare cases. Similarly, your product size, this may also change, but in very rare cases. And product price, this may change, but again not in regular interval of time. So this is like also kind of a master record where it has been created for the first time when you're trying to launch a new product in your store. So this kind of details will be created only once and changes in very rare cases. So I could say that this is my product dimension table. I could say this is my product dimension table, and I could say this is my either a customer dimension or it can be a employee dimension table. It could be anything. So because all these details is been related to both either customer or employee. So I could say that this is my dimension table. Similarly, I can have my location dimension, or I can have my vendor dimension, because vendor we know that once you start a store, suppose you kept all your products inside that, right? So once you sold out, you need to refill the store with products. So where do you get the products, right? So you need to contact your vendor. So again, you'll be having your vendor's first name, vendor's business name. So you'll be having your vendor's middle name, last name, again vendor's email ID, vendor's phone number. So I could say that is my vendor's dimension table. So when I say dimension, then one thing you should keep in mind that, okay, this contains my master data. So what is a master data? A master data is nothing but it is the data which is created once and changes very occasionally. That is my master data. Okay. So now let's see the other one. What is a transactional data? So transactional data is nothing but, so this is nothing but this is the data which has been generated due to the business done by the master data. This is the data generated due to the business done by master data, done by master records. So suppose think that John. So John is nothing but it's a name of a person. It's the name of a customer. So I could say that this is your master data, right? So suppose John went to a store and purchased a product. Suppose he went to a Walmart. John went to Walmart and finally he purchased one product. Suppose think that he purchased one table, suppose, just in case. So when he purchased a table, automatically what happens? I'll be getting a invoice with me. So in that invoice, it contains all the details like product name, what is the quantity he took, quantity per price, right? And you also will be having which counter he took that particular product and who is the employee ID who sold the particular product, which is the location, in which location this Walmart resides, location ID, and your VAT and your discount, and finally your grand total. So all these things will be generated automatically once you do a small business like buying one product in your particular store. So this, among this, you can find like quantity per price, counter number, and your employee ID, location ID, VAT, discount, and grand total. All this data will be generated only when there is a transaction happen. Unless and until there is a transaction happens, nothing is generated over here or nothing is produced over here. So when this transaction will happen, only when a particular person, or I could say that whenever a master data comes and when he does a business, due to that business, what happens? A data has been generated. So what kind of data is generated here? This is the data has been generated. So such kind of data is called as your transactional data. So transactional data is nothing but it is a data generated due to the business done by the master data, I could say. So such kind of data which contains almost all numerical values, quantity per price, counter number, employee ID, location ID, VAT, discount, grand total, all these numerical values, such kind of transactional data should also be stored somewhere in my table. And the table which stores such kind of transactional data is nothing but it's called as my fact table. So dimension table always contains my master data, whereas my fact table contains my transactional data. Okay, and these two dimension tables and my fact table resides in my OLAP database. Okay, so this is all about my master data and my transactional data. At the same time, we also came to know that what is a dimension table and what is a fact table. From now onwards, when I say it is a fact table, then you should keep in mind that it contains all your transactional data and all are numerical values. So no theoretical values will be available in your fact table. Only the transactional data will be available in your fact table. And when I say it's a dimension table, then you should keep in mind that this is it is a table which contains your master data. It contains your master data, and it is the data which is created once and changes very occasionally. Okay, so this is about your dimension table and your fact table. So next let's try to learn the different types of schemas. So we have three types of schemas here. One is like star schema. Second one we have Snowflake schema, and third one we have fact constellation schema or galaxy schema. So this is different schemas available for us in that as a part of your data warehousing concepts. So let's try to understand what is a star schema. So star schema, before getting into that, we already know that all my master data resides in my dimension table, and we know that all my transactional data resides in my fact table. So let's see how could we have that in a small diagram over here. So now we know that, so this is my fact table where it contains all my transactional data like VAT, your quantity per price, and your counter number, everything. So this is nothing but my fact table. Okay, and also we know that we have a dimension tables here. So this is my, I could say like a customer ID. So this is my customer dimension table, and this is my I could say product ID. So this is my product dimension table. So this is my like a location ID where I'm having my location dimension table, and this is my employee ID where I'm having my employee dimension. So now we have, whenever transaction happens, if you see the invoice, so over there you can see the details of the customer, you can see the details of the product, you can see the details of the location, you can see the details of the employee ID, and also you can see the transactional data done by the customer like the quantity per price, everything. But we know that the customer details will be sent to my customer dimension table, which you see here, and the product details will be sent to my product dimension table, if you see here, and the location details will be available in my location dimension, and my employee details will be available in my employee dimension. Finally, my transactional data is available in my fact table. So in order to get my whole transaction out, that means I should get my data from my customer dimension, I should get the data from my product dimension, at the same time I should get the data from my location as well as my employee dimension, and finally my fact table as well. That means I need to join all of my 5 tables which you see on the screen here. So without joining the tables, I could not get my whole transaction done by a particular customer, right? So in order to join 2 tables, now the basic fundamental thing is like, in order to join 2 tables, I need a common column. So without having a common data between 2 tables, I could not join 2 tables. So first of all, how could I join? See here, this is my primary key I'm having at my customer dimension. So this is my primary key having at my product dimension. So this is my primary key having at my location. Similarly, primary key having at my employee ID. So how could I join my customer with fact, or product with fact, or location with fact, and finally employee with fact. So if you see here on the screen, I could not see any common column over here. But the basic fundamental is that in order to join two or more tables, we should have common columns. For that reason being, what I did is like, I created my foreign keys at my fact table so that I could join my dimension and fact tables so that I could get my whole transaction out. For that reason being, I wrote like customer ID over here. Similarly, product ID over here, location ID over here, and finally my employee ID over here. So now make all these things as a fact table. Now what I'll do, I'll join my customer ID, which has a primary key in my customer dimension, with my foreign key of my fact table. So these are nothing but my foreign keys over here. So from product to product, location to location, and finally employee to my employee ID. So since now we have a common columns between my dimensions and fact table, now I could easily join the data, all the tables, and finally I could get my whole transaction out done by the customers. Okay, so this is nothing but here the fact table is sitting in the middle, surrounded by multiple dimension tables, where your dimension tables and your fact tables are connected together so that we could get the whole report out. And if you observe, this looks like a star. See here, this looks like a star. That is the reason being, this is called as your star schema. So star schema is nothing but only one thing I could say, that it's a fact table sits in the middle, surrounded by your dimension tables, where your dimension tables and your fact tables are related to each other with the help of your primary key and foreign key constraints. So with the help of these common columns, I could get my whole transaction out. Okay, so you can see the same thing in here. See here, this is the star diagram of a star schema, where the sales is a fact table sales. So sales contains all your transactional data, and these are nothing but your different dimension tables surrounded. This is a location, this is a time dimension, supplier dimension. I could say like it's a vendor dimension, customer, product, employee. So all these are nothing but different dimension tables surrounded by my fact table. So all these are interlinked to each other with the help of your primary key and foreign key relationship. So I could show you one more thing. So this is your actual thing here, if you see. So see here, yeah, see, if you see here, you can see your sales fact, where it contains your, this is the price, quantity, total price, VAT. This is your transactional data. You can also say this as your measures. So measures or your transactional data or your fact, all these three relates to same thing. Your measures or your transactional data or your fact, all these three belongs to same. So if you see your sales fact, sales contains your, see all these, nothing, this is the primary key of your fact table, and see here address ID, this is coming from my address table. So this is the primary key over here, and this here it will be foreign key. So branch ID, it's coming from branch, and it's like a brand ID, it's coming from my brand, and so customer ID coming from my customer, payment method code, it's coming from my reference payment methods. So you can also have different keys over here like suppliers, reference sales status, reference product categories. All these things are nothing but my foreign keys. So for sure you should have your primary key generated in your dimension table, and that primary key should be sent to my fact table, so that later on I could join my dimensions and fact table together so that I could get my whole transaction out. So this is your actual star schema. Generally you is available which in your real-time projects. Of course I did not keep any other columns over here, I just stored only the primary keys. Okay, so we also have different things like so if you talk about address, so you'll be having your address line 1, address line 2, your state, your city, everything will be available over here. But since here I'm just showing you only your primary key. Okay, because we are talking about only primary key and foreign key. So overall, I could say that your star schema is nothing but it's a combination of your fact tables and dimension tables, where these tables are being interlinked, or these tables can be connected with the help of your primary keys and your foreign keys. Okay, so that's all about your star schema. And one more thing I would like to say, that whatever the tables you have in your star schema, all those are denormalized tables. So we have denormalized tables in star schema. We have denormalized tables in star schema. So what do you mean by denormalized? So whenever you have the whole related data, or when you have a dimension related stuff, the whole dimension related stuff in a single table. See here, this is the 4 columns you can see, like product name, product color, product size, product price. So these 4 columns are related to single table, and this is the only stuff we have related to your product. So whenever the whole stuff is available in a single table, then it's called as your denormalized table. Denormalized table. Or suppose like here, when I say about my customer, suppose this is first name, middle name, last name, permanent address, your temporary address, email ID, phone number, all these things relates to in one table. So when you have the whole department stuff, whole dimension, the whole table related stuff in one table, then it's called as denormalized tables. Suppose this particular table has been split into multiple tables. Suppose in this scenario, I also have like city name, state name, country name. So this is the whole stuff related to a particular customer. So you no need to look into any other different tables for your customer details. If you look into your customer dimension, then more than enough, because you will be having each and every minute detail information of your particular customer in this particular table. In such scenarios, it is called as your denormalized table. Now, what is normalized table? So normalized table is something like when you're trying to split the whole table. Suppose this is my whole customer dimension. I'm trying to split my customer dimension into multiple dimensions. Like suppose here up to this particular level, I have my one table, and from here I'm trying to create the other things like this is my second part, city ID. So here I'll be having my, okay, let me write down at the bottom, it's be confusing here. So suppose I have my first name, middle name, last name, and your email ID, your phone number, your city ID. This is one table, and where here I'll be having one more like a customer ID. So this will be my primary key, and this will be my foreign key. Later part, the same table has been split into multiple tables. Like this is the second table I'm having here, city ID. This will be my primary key. Here, city name, state ID. So this will be my foreign key. Similarly, I'm having one more table related to the same customer. That is my state ID. This will be my primary key. state name, this will be, and my country ID. So this will be my foreign key over here. So similarly, I'll be having one more table, country ID. So this will be my primary key, and finally my country name. So if you see here, earlier you have all this information single table, as you see here. You have all this information in single table, but now what happened, I'm trying to split the same thing into my multiple tables. If you see here, so this is my table 1, this is my table 2, this is my table 3, and this is my table 4. So now table 1 and table 2 can be related with help of my what? City ID of my primary key, second table, and foreign key of my first table, city ID. Similarly, my second table and third table can be related with help of my state ID column of my state table and my state ID column, foreign key of my city table. Similarly, finally, my country related stuff, see here, country ID of my country table can be related to my country ID of my state table. So in here, I am trying to split my single table information into multiple tables. When we have such kind of tables, then when we split the information of a single table into multiple tables, then such kind of tables are called as normalized tables, where earlier we have whole information in a single table, right? The whole information in a single table. Such kind of tables are called as your denormalized tables. And now in our star schema, all my dimensions are denormalized. That means whatever the dimension it is, it contains the whole stuff inside it. So the same dimension table is not been split into multiple tables. So this is contained, this such kind of schema is called as your star schema, and yes, you have a chance of having duplicates in your star schema. So you may be having duplicates in your star schema. So I could say that, so what is a star schema? A star schema is nothing but it is a schema where your fact table sits in the middle, surrounded by multiple dimension tables, where your fact table and your dimension tables are interlinked or can be joined with help of your primary key and foreign key relationships. At the same time, all my dimensions are denormalized tables, and there is a chance of having redundancy of my data. Okay, so now what happens just in case if I split my tables of my dimension table? Then don't worry, yes, we do also have such kind of scenario, and such kind of scenario is called as your Snowflake schema. So when we try to split, as you see in this on the screen now here, then such kind of tables are called, such kind of schema is called as your Snowflake schema. There's no change apart from this, everything is same. So similarly, there also you can see like your fact table sits in the middle. See here, you can see like the fact table sits in the middle surrounded by dimension table, but each dimension is again split into some sub table. If you see here, see here, so this is my product dimension, this has been sub divided into one more sub, like product category lookup. So these two belongs to one product dimension. Similarly, this two belongs to my location dimension, and this two belongs to my branch dimension or organization dimension. This two belongs to my time dimension. So earlier you can see these two information in a single table and these two information in a single table, as similarly these two and these two in a single table. In such scenarios, such kind of schema is called as a star schema, and the tables are called as denormalized, where there is a chance of having redundancy of data. But when you try to split the tables in such a manner like this, few information in one table and some other information in some other table, like splitting up the same dimension table into multiple dimensions like this, then yes, such kind of schema is called as your Snowflake schema, and those tables are called as normalized tables, where you do not have any kind of duplicates in here. Okay, so let's try to see the differences between star schema and Snowflake schema over here. So this is Snowflake schema, and I would write like star schema. So what is the first point? The first point in here is like it contains normalized tables, where this one it contains denormalized tables. Second one, there is a chance of having duplicates, where in this no duplicates. And rest thing is like coming to the performance wise, which is better, Snowflake schema or star schema. So I could say that Snowflake schema is always the performance will be degraded, where in your star schema performance increased. So how could I say this? So why star schema performance increases, even though I'm sorry, I think I wrote it wrong. Normalized, denormalized. This one should be here. I'm sorry. So here no duplicates. Sorry for the confusion. So this one no duplicate. So here performance will be degraded, and this one performance will be increased. Why? See here, if you observe here, suppose I want to get the whole report. I'm going to my star schema over here. If you see here, when I want to join the data, I'm joining here like address and fact table, 1 join, brand 2, optician branches 3, 4, 5, 6, 7, 8 and 9 joins. So over here I'm trying to get with 9 joins, or let me go with a simple one more example, like here in this scenario. Suppose the same customer table here I'm splitting this customer table into multiple tables, suppose. So this one is split into multiple tables, and this is been split into multiple tables like this. Suppose they think that your customer information is resides in 1, 2, 3 and 4. Okay, and this is called as a Snowflake schema, and this is called as your denormalized tables, and these are called as your normalized tables. Suppose now I'm trying to join the data, because at the end of the day I need to generate my report. So from where do I get my report out? I'll be getting the report out of my dimension tables and my fact tables. So now when you are in Snowflake schema, I want to generate a report, then first thing I need to join these two. This is my first join. Later on I need to join these two. This is my second join. Later on I need to join these two. This is my third join. And later on finally I need to join these two. This is a fourth join. So you need 4 joins only for your customer data. So what about your product, just in case it got splitted out? And what about my location, and what about my employee? So overall think that 4 for my customer, 4 for my product, 4 from my location and 4 from my employee. So overall you are taking 16 joins to get out the report. So think, how much time does it take to join those many tables? 16 joins, it's not a small thing. It's very costly operation. So in real time you'll be having millions of records in each and every dimension table. Then how could you join, how could you think how much time does it take to have 16 joins? So it takes very long, very huge time. It may, we are not sure how much time does it take. It takes very huge. The performance has been impacted for sure. Then suppose I am going with my star schema. In star schema we know that the whole information resides in a single table. In that scenario I need only one join. I need only one join. For my this one, similarly second join, third join and only fourth join. So overall I could say we need only 4 joins when compared to your star schema. So in star schema you go with your 4 joins only, but in your Snowflake schema you're going with 16 joins. Now which is better? Obviously your star schema is better. For that reason being, I told you that in here that your performance will be increased when you go with your star schema and performance will be degraded when you go with your Snowflake schema. This is only like because the tables are normalized. So even though you have no duplicates in here, but still the performance is very degraded because of your having multiple tables over here. But even though you have a chance of having redundancy of the data or duplicates, since you have only few tables to join, we go with always star schema maximum. It's not a mandatory that you should go with star schema only, but it's totally based upon the requirement of your client. And coming to the duplicates, don't worry, we can remove that by writing the logic. So here I'm trying to join more quicker in star schema than compared to my Snowflake schema. So always star schema is much better than Snowflake schema. Okay, so that's all about your Snowflake and your star schema. So next is like we left with one more, that is nothing but your galaxy schema or your fact constellation schema. So till now we saw that only one fact table sits in middle and surrounded by multiple dimension tables. Now suppose I have multiple fact tables like fact 1, fact 2, fact 3. Now also have my dimensions like D1, D2, D3, D4, D5, D6, D7 and finally my D8. So I could connect like this. So if you see here what's happening here, multiple dimension tables and multiple fact tables are being connected to each other. So in general, in real-time project, you will not have only one fact table, but you'll be having multiple fact table. For example, suppose you're dealing with some kind of loans, okay, then you may have like loan balance history or like your loan informations, what happened to your loans previously, all those things. Or suppose you are not paying, or suppose some other customers are not paying the loan, then for sure those people will come under default. So who are under default? So these are different categories you are having, right? For each and every category you'll be having your own fact table. So this is for your loan balance history, so this is for your loan information, this is for your loan default events, whatever you have here. So all these things comes into each and every fact table over here, right? So combiningly all the fact tables belongs to a single application of my project. Okay, and each and every fact table has their own dimension tables again. So overall, for the application wise, if I want to get the whole report out of my whole application, then yes, for sure I should join my all my fact tables and all my dimension table. Such a scenario, it comes under your fact constellation or galaxy schema. And yes, again, each dimension may be a normalized or may be a denormalized. That's purely based upon your requirement of the client. So it's not a mandatory that always you should have only denormalized tables, or it's not a mandate that you should always go with your star schema or Snowflake schema. It's purely based upon your requirement and how your project architect decides based upon the business of your end user, based on the business of your end user. Okay, so that's all about your fact constellation and your galaxy schema. So we'll stop here for today. So next session we'll try to learn what is the architecture of a data warehouse, where it helps us to understand from where the data comes and from where it goes, in what are the different levels we are having, what are the different stages are we are having, and finally how we try to insert the data into our dimension tables and our fact tables. It's very important to know. So let's see this in the next session. Okay guys, then hope you understood your types of schemas and hope you understood your OLTP and OLAP databases. So let's discuss more about architecture in the next session. Okay, have a great day guys. Bye bye.